Good morning, everyone. I am Mahima Saxena, Assistant Professor at CSE Department in AKGC. Today, I'm going to present my topic. Today's topic is locking protocols. Now, what is in this topic? In this video lecture, I'll explain what is locking protocols, what are the uses, why are we need them. So now we start the lecture. Basically, first we need to understand what is concurrency control. Concurrency control is the working concept that is required for controlling and managing the concurrent execution of the database operations and thus avoiding the inconsistencies in the database. For maintaining the concurrency of the database, we have the concurrency control protocols. Now, these are the protocols basically for avoiding failures or for avoiding inconsistencies in the database. We need concurrency control protocols. We need to, for current proper concurrent management or proper concurrent executions, we need concurrency control protocols. Now, what are the concurrency control protocols? Basically, concurrency protocols ensure atomicity, consistency, isolation, durability, and serializability of the concurrent execution of the database transaction. Therefore, these protocols are categorized as log-based concurrency protocol, timestamp concurrency protocol, and validation-based concurrency protocol. Now, basically, atomicity, isolation, consistency, and durability. These are called asset properties. These are used for ensuring the proper execution of transaction. This is where we can use them. Now, coming to the topic, now what is log based? These are the three protocols which are called as concurrency control protocol: log based concurrency protocol, timestamp concurrency protocol, or validation based concurrency protocol. Now, the first one is log based protocol. It is a type of protocol any transactions cannot read or write until it acquires a appropriate lock on it. Basically, if a transaction T1 is want to read a data item A, then it will acquire a lock on data item item A, and that after perform read or write operations, whatever the transaction want to perform. But performing for any operations, we need to acquire lock. Now we have two types of lock: shared lock and exclusive lock. In shared lock, the transaction can only perform read function, and in exclusive lock, the transaction perform read and write both the functions. Now I'll explain the definition. What is shared lock? Basically, it is also known as read only lock. In shared lock, the data item can only read the transaction. It can be shared between transactions because when the transaction holds a log, then it can't update the data on the data item. Basically, if we are performing read operation, then the updation of read item, then the updation is not performed in shared log because we are only reading the data item. Now, no updation is required. We are just reading. In shared log, no updation is possible. Now, what is exclusive log? In the exclusive log, the data item can be both read as well as write and written by the transaction. Basically, the lock is exclusive, and in this lock, multiple transactions do not modify the same item simultaneously. In shared lock, multiple transactions can read data item because no updation is performed. But in exclusive log, updation is performed and multiple transactions do not modify the same data item simultaneously. Because suppose, for example, transaction T1 is trying to T1 is acquired a lock on data item B, and it performed read operations, and now T3 is also acquire a lock on data item TB. Then the value is changed. If after performing the updation with the help of T1 on data item B, if T3 wants to acquire at that time, then the value will change and the calculation will be wrong. Because of that, only one transactions at a time can acquire an exclusive lock on particular data item. When it will release the lock, then the other transaction will acquire lock, and this process will continue. Now, 4 types of lock protocols: simplistic lock protocol, pre-claiming lock protocol, two-phase locking protocol, and the fourth one is strict two-phase locking protocol. Now the first one is simplest lock protocol. It is the simplest way of locking the data while transaction. This is the simplest way of locking the data while transaction. Simplest lock based protocol allow all the transaction to get on the lock, to get the lock on the data before insert, delete or update on it. It will unlock the data item after completing the transaction. This is the simplest lock, and this is generally not we are using it. We generally used the third one and the fourth one. I'll explain. Now the second one is pre-claiming lock protocol. Now what is pre-claiming lock protocol? Basically it evaluates the transaction to list all the data item on which they need to lock. Before initiating an execution of the transaction, it requests DBMS for all the lock on all those data items. If all the locks are granted, then this protocol allow the transaction to begin. When the transaction is completed, then it releases all the locks. If all the locks are not granted, then this protocol allow the transaction to roll back and wait until all the locks are granted. This is called as pre-claiming lock protocol. The third one is two-phase locking protocol. In two-phase locking protocol, basically in this protocol divides the execution of the phase of transaction into three parts. The first one is where the transaction starts. It seeks permission for the lock it requires. The second part is the transaction acquires all the lock. The third phase is started as soon as the transaction releases its first lock. In the third phase, the transaction cannot demand any new lock. It only releases the acquired lock. This is called two-phase locking protocol. This is the most widely used protocol we are using for our transactions. Now, in this phase, we have two phases, growing phase and shrinking phase. The first one, in the growing phase, a new lock on the data item may be acquired by the transaction, but none can be released. Basically, in growing phase, we can acquire data items, but we can't release any data item. In shrinking phase, we only release data items, not acquired any data items. In shrinking phase, existing lock held by the transaction may be released, but no new lock can be acquired. Suppose we have an example. If lock conversion is allowed, then the phase can be given as unlocking of lock from upgrading of lock from SA to XA. Basically, S is for shrinking phase and X is for growing phase, as allowed in growing phase. Now, downgrading of lock from X of A to S of A must be done in shrinking phase. Now, the last one is strict two-phase locking protocol. The first phase of strict 2PL is similar to 2PL. Basically, strict 2PL is like an upgraded version of 2PL. The first phase is similar to 2PL, and the first phase is similar in both 2PL and strict 2PL. In the first phase, after acquiring all the locks, the transaction continue to execute normally. The only difference between 2PL and strict 2PL is that strict 2PL does not release a lock after using it. Strict 2PL waits until the whole transaction to commit, and then it releases all the locks at a time. Basically, when all the operations are performed by all the transaction, then it will release all the locks at same time. Strict 2PL does not have a shrinking phase of a lock release. This is called strict two-phase locking protocol. The next topic is multiple granularity. It can be defined as a hierarchical breaking up the database into blocks which can be locked. The multiple granularity protocols enhances currency and reduce to lock overhead. It maintains the track of what to lock and how to lock. It makes easy to decide either to lock a data item or to unlock a data item. This type of hierarchy can be graphically represented as a tree. Suppose, consider an example. A first level or higher level shows the entire database. The second level represents a node of type area. The higher level database consists of exactly 3 areas. The area consists of children nodes, which are known as files. No file can be represented in more than one area. Finally, each file contains child node known as records. The file has exactly those records that are its child nodes, and no records represented in more than one file. Hence, the level of tree starting from top are as follows: database, area, file, and record. These are the levels. This is the example of multiple granularity tree in hierarchy. The highest level shows the entire database. The levels are below as file records and file records and fields. The next one is intention mode log. Basically, intention shared. It contains explicit locking at a lower level of the tree, but with only shared lock. Intention exclusive. It contains explicitly locking at a lower level with exclusive or shared locks. The third one is shared and intention exclusive. In this log, the node is locked in shared mode and some node is locked in exclusive mode by the same transaction. Basically, transaction T1 is acquired a data item in shared mode like on A and in exclusive mode on B. Different transactions can perform in both the modes. The last one is compatible metrics with intention lock mode. This below the table describes like what is the compatibility of a metrics for these locking protocols. For example, transaction T1 should follow the lock compatibility metrics. Transaction T1 firstly locks the root of the tree. It can lock it in any mode. If T1 currently has the parent of the node locked in either in exclusive mode, in intrusion exclusive or intrusion share mode, then the transaction T1 will lock a node in S or IS, basically sharing or intrusion sharing mode. The T1 currently has the parent of the node locked in either exclusive mode, intrusion exclusive mode, or shared intrusion exclusive mode. Then the transaction T1 will lock a node in any of the mode. If T1 cannot previously unlock any node only, then the transaction T1 can lock its node. If T1 currently has none of the children of the node locked, then the transaction T will unlock a node. This is the example. Now observe that a multiple granularity that locks are required in top-down order. Lock must be released in bottom-up order. If transaction T1 reads record RA9 in the file FA, then the transaction T1 needs to lock the database area A1 and file FA in exclusive mode. Finally, it needs to lock RA2 in sharing mode. If transaction T2 modified records RA9 in the FA file, then it can do so. So after locking the database area A1 and file FA in exclusive mode, finally it needs to lock the RA9 in exclusive mode. If transaction T3 records reads all the data in file FA, then transaction T3 needs to lock the database and area A in sharing mode. At least it needs to lock FA in sharing mode. If transaction T4 reads the entire database, then T4 needs to lock the database in S mode. Thank you so much for this lecture.